Hello, in this video we're gonna talk about C++ normal functions, C++ inline functions, C++ functions definitions, and C++ programs with both C++ normal functions and inline functions. Let's go right now. What is a C++ inline function? What is a C++ normal function? By definition, in computer programming, a function is a group of statements which are executed once the function is called, and the execution of those statements will accomplish the specific task. So, an inline function and a normal function's definition are different because the syntax of inline function definition contains inline keywords. So this is the syntax of inline function definition because we have inline keywords which is followed by return type of a function and the function name containing some parameters, and here we have the function body. So the first line is called the function header whenever this is called the body of the function. So the function definition of a normal function does not contain inline keywords. So you see that the difference between normal function definition and the inline function definition is only the presence of inline keywords in the definition of inline function. So, what is an inline function? During the compilation and execution of a C++ program containing a user-defined function, if you have defined an inline function, the compiler will copy the codes from function definition directly into the codes of the calling of the calling statement into the calling function. Here the calling function is the main function because we always put function call statement into the main function. So the difference existed during execution of these two functions. So we have two diagrams where the first diagram shows a normal function and the second diagram shows inline functions. So we are going to see how these two functions are executed or are compiled by a C++ compiler. On this diagram, you see that there is the transfer of flow control to the user-defined functions or to the definition of the normal function. It means that once the compiler sees the function call statement, it stores the argument of the function call statement into the stack, and then it transfers immediately the flow control to the function definition. So after execution of the function definition, the compiler gets back to execution of the codes of the calling function after function call statements. And after executing the whole program, the compiler finishes to compile the C++ program into consideration. So here we say that the compiler transfers the flow control to the definition of normal function definition, or in other words, we can say that we have to separate memory location where one contains function calling instructions and another one contains function definition instruction. This is the execution of a normal function. But on the second diagram, we have an inline function. So this is an inline function because during execution, once the compiler encounters the function call statement, it directly copies the whole definition means the function header and its function body of inline function into the inline function call statement and execute the entire program. So we can say that in main function, when the normal function is called, the control is transferred to the definition of the called function. But when inline function is called, the function definition codes will be inserted into the point of the inline function call statement. Now we can compare normal function and the inline function. So the compiler replaces, in inline function, the compiler replaces the function call with the function definition codes and compiles the entire codes. But at normal functions, the code is compiled first and then afterward converted to the executable codes. So here there is the transfer, or just the compiler transfers the flow control of the program to the normal function definition. Inline function does not create function call overheads as the function definition code is replaced in the program. But the normal function creates overhead and when a function call encounters. Inline function in the repeat the call such as in a loop waste the memory but save the CPU time to execute that call. We can say that C++ inline functions enhance the execution time or just increases the efficiency of C++ program. In other words, the CPU time is small compared to execution of normal functions. All functions inside the class in C++ are implicitly inline function. So in object-oriented programming, we define the class, and a class combines data members and member functions. So we can define member functions inside the class or outside the class. So all member functions defined inside the class are inline by default. Whenever all functions defined outside the class are normal functions. So this means that in order for the programmers to save the efforts, the programming efforts, all the member functions with fewer codes must be defined inside the class definition so that they become inline function. But all member functions which contains many statements, will be defined outside the class, so that they don't become inline functions by default. So using too many inline functions increases the executable file size because of the application of the same code. But using many normal functions does not affect the file size after compilation. So we can see example of normal function or example of a C++ program containing normal C++ function. So here we have a function which is called print_sum, whose return type is void. So as there is no inline keywords here, this is a normal C++ function. So this function contains two parameters, parameter called num1 and the parameter called num2. And the target of this function, or the statements of these functions, is this one: cout num1 plus cout2 and the new line. So in the calling function, which is main function, we have two calling statements. So we have print_sum, which has been called by value and been given 60 as the first argument and 40 as the second argument. We have also the second function called statement, where the values of arguments are 10 and 30 respectively. So during execution of this program, in the calling function on the main function, once the compiler encounters the function called statement of the normal functions, there is immediately the transfer of flow control to the function definition. It means that the copies of these arguments will be copied into the formal parameters of these normal functions, and its functions, its codes are executed by calculating the sum of these two values. So we have a C++ program. We have the normal function, which is called the print_sum. Its return type is void. We have two parameters, and this is the body of this function containing the two statements. The first one, cout num1 plus num2. The second one is cout new line. So this is a group of statements whose target is to calculate the sum of two values of the arguments passed to the function during the function call, and then jump to the new line. So the calling function, which is main functions, contains two function call statements. So once the compiler encounters with the function call, it immediately transfers the flow of control to the function definition, as I have told you. So after execution of this program, the output will be 140, because the sum of first two arguments is 100, and jump to the next line where the sum of two arguments is 40. So let us see a C++ program with inline function and discuss about how C++ inline function is compiled and executed by C++ compiler. So it is an inline function because the programmer has used inline keywords here. Inline function is called print sum. Its return type is void, and this inline function has two parameters. This is the first parameter and this is the second parameter, and this inline function has the body containing the following statement. By looking at the inline function statement, we see that this function will calculate the sum of two numbers. So in the calling function, which is the main function, we have two calling statements. So during the compilation, once the C++ compiler encounters this inline function statement call, there is no transfer of flow control to the function definition, but it immediately takes or copies the codes, all the codes of function definition in the place of function call statement, and compiles the entire program. So here we have a C++ program containing inline C++ functions, because we have used the inline keywords. And after writing this source code or source file, the compiler, C++ compiler, compiles this C++ program, and the processor or CPU execute the program to give the following output. So we can use this diagram to see what does happen during a compilation. So here we have a C++ program containing inline C++ function, because we have inline keywords here. And the C++ function is called the print sum. These are the two parameters, and we have this inline C++ function has the body containing the following statements. And in the calling function, the main function, we have three distinct inline function calling statements, and here this is called by value. So during compilation, once the C++ compiler encounters the function, the inline function call statement, it directly copies the inline function definition into the inline function call statement you see here. So, and the program is compiled entirely, and the whole program is compiled without transferring the flow control to the inline function definition, or simply after copying the function definition statement in the place of inline function call statement, the execution immediately, the all statements are executed as they are stored within the single memory location. So we can compare inline function and a macro function. So inline function is a feature used in C++ to enhance the performance of a program, or just to reduce the execution time, or simply to fight against function call overheads. But macro function is also a function which is used in C programming language to enhance also function, or just to optimize the C program. So, but there are some differences that we can discuss about. So inline functions are expanded by the compiler. Remember that the expansion is the process of copying the function definition statement into the function call statement. So macro are expanded by preprocessor. Inline functions are defined by inline keywords. Whenever macro functions are defined by the preprocessor, by the keyword define, which is followed by a preprocessor directive. So inline functions can be defined within the class as well as outside the class. But macro functions are defined at the start of the program. Inline functions can access data members of a class, but macro function can never access data members of a class. All the parameters of inline functions are evaluated just one time, but in macro functions the parameters are evaluated each time the macro is used in the code. Inline function can easily debugged as they are executed during compiler time. To debug means to remove the bugs or the errors. Macro functions cannot be debugged easily because they are not executed during compiler time. Inline functions which are short, automatically declared as inline function. So inline functions must be short, must contain fewer statements in order to save the memory, in order to not consume memory space and save CPU time. But macro functions has to be defined specifically. So inline functions are defined by using the following operators, curly brackets, but macro functions are defined without using any symbol, or there is no need to use the symbols to show the end of the end or the termination of macro function. Finally, we can discuss about the advantages of inline functions in C++ programming. So the compilation speed of the program get increased since inline functions prevent function call overhead. So there is no function call overhead because the compiler, because there is no time to transfer the flow control from the calling function to the function definition. Inline functions that are small in length can be used in embedded systems, as well as since the functions yield lesser code than the function call and return. So embedded systems, these are the computing devices which run the same codes each time they are working. So one of the application of inline functions is to put them into embedded systems. Inline functions also prevent the overhead of function return calls. So there is no overhead, there is no extra work during execution of C++ programs containing inline functions. There is no additional resources, no additional times. So inline functions prevent the programming or the function call overhead. Inline function allow the compiler to perform some optimization on the body of the function that is content specific in nature. And during the invoking or calling of the function, this function prevents the overhead and push and pop stack variable. So we can summarize this content by saying that inline functions are the functions which are used in C++ programs to optimize the performance of C++ program. Thank you. See you next time.